we will be going on to our next section by Dr. Mustaq sir. So I will give a brief intro about who is Dr. Mustaq. So Dr. Mustaq Ahmed is presently working as head of department in Department of Computer Science at MNIT Jaipur. He has more than 25 years of teaching experience. His research domain includes network on chip, embedded systems, blockchain technology, IoT, cloud computing, wireless sensor
Oh,
networks, fault tolerant system, and high speed overlay networking. He has
Dr.
published
Ahmed sir,
more
are
than
you there?
80. Hello,
I think sir has shared his PPT.
hello. अरे मेरा आवाज नहीं आ रहा है। Hello, am I audible? Am I audible?
Sir, you
Hello.
are not audible right now, sir.
मेरा भी आवाज नहीं आ रहा है। आवाज आ रहा है?
Yeah. Jitendra, you are audible. So tell me, my slides are visible?
Sir, screen is there, but your voice is not clear, sir. Means we are not getting your voice.
Hello, hello. अरे
Hello?
hello.
Hello?
Hello.
Oh, that's
Am I audible, sir? Hello.
Hello?
Hello. Am I audible, sir?
Hi, you are audible.
So, sir, I will be giving brief description. So we will move on to our next session. So I will be giving brief description on who Dr. Mustaq Ahmed is. So Dr. Mustaq Ahmed is presently working as head of Department of CSE at MNIT Jaipur. He has more than 25 years of teaching experience. His research domain includes network on chip, embedded systems, blockchain technology, IoT, wireless sensor net, fault tolerant system, and high-speed overlaying network. He has published more than 80 years in various international journals and conference. He is a PI, co-PI in 3 research projects, 1 international patent and 1 Indian patent. He has successfully guided 6 PhDs and 21 PG research scholars and currently supervising 7 PhDs. He is a member of Board of Studies of Gujarat Technical University, Board of Studies member of Amity University, Jaipur, and member of Research Board of UEM, Jaipur. He is a fellow IE India, life member of ACM, life member of ISTE, life member of ACCS, member IEEE, and member IENG. So, handing over
Sir,
to
your
Mustaq,
voice
sir.
is not audible. You are not audible, sir.
No, he's audible. I listen carefully. It's okay. Am I audible?
Yes, sir, you are audible.
So shall I start?
Yes.
Shall I start?
Yes, sir, you are audible.
So good afternoon, everybody. Good morning, because it is 11:15. So pertaining to this healthcare system, which I am coordinating this faculty development program, the emphasis of this was made in order to realize the importance of using this blockchain and AI in the healthcare system. So there are a lot of issues in the healthcare which requires the authenticity, reliability, and security issues pertaining to this healthcare are there. So in that case, use of this technology would give this improvised performance in the healthcare system. Pertaining to that, a lot of research is currently going on. The various key areas which are there and which need to be explored. And we have gone through some part of that in our institute, and very good research work that we shall share, and the gap area which are provided where you can the participant can work on, and that will be a value addition. So pertaining to this part which I am trying to cover is the two part. One is the use of this blockchain in the healthcare system. A part of that, Dr. Jitendra Goyal has already covered, but pertaining to this, the signature, how that has been created and stored in the blockchain, that part I shall cover. And then the uh, a predefined, or you can say that the technology, AI technology, where we do not require to train the system, but automatically that would able to detect or generalize the use of the technology for the healthcare systems. Specifically, that was we observed that the malicious and malified intention people have. Uh, exploited this healthcare system during the COVID-19 vaccine distribution. So pertaining to that, the part of that research part that we have gone through and it provided the solution, that part we will discuss over here. So as you may be aware about, this blockchain is a important part where the signature values or that hash value that need to be stored, and any type of the data, whether that may be a text, that may be image, audio or video, all these, irrespective of their size, their signature value of the 256 that need to be stored in the blockchain, that gives it this permanent marking that having that information which is being generated, that is a genuine one. If it is being used, the receiver will have to verify that whether that is a genuine or not. It has to be compared with that signature hash values which has been stored in the blockchain of the blockchain. So if the comparison of that is made without any change, or the hash value is not changed, in that case we can say that this value is or that information is a genuine information without any alteration. So as you can see that a series of such type of the blocks are being created in order to provide those information on the block. So pertaining to this, various type of the application that are there, where such type of the information storage in the blockchain is being used. Specifically nowadays, the cryptocurrency is the major part where the normal public are involved. So what that was covered by the Dr. Jitendra is also I am mentioning over here, pertaining to this market tree where a multiple images, all these multiple images, T0, T1, T2, T3, all that the test information of the patient that is to be stored in the block, and this information requires to be stored prior to that. The hash value of that is to be generated. So any medical prescription of the doctor who may have provided multiple tests or their information. So the secrecy and their privacy of any person of importance that need to be there while storing such type of the information. So the challenges are there, that how we can secure this information which has been stored in a distributed architecture. Second is how that we have to authenticate that this information is not being altered. In that case, pertaining to that information has to be stored in the blockchain. So combining all those information of a patient in the healthcare, each and every record has to be has or that need to be signatured in the digital signature, which we are claiming over here as a SHA-256 hash values, which has to be stored. So all these hash values in this market tree would require a single hash value in the block and with the time stamp. So that marking of that would be done in the blockchain. So in doing this talk. If somebody has any query, please put that on the chat box so that I will compile that and give you the answer as much as possible. So in the block, a 1 MB size of the block has the version is a hash value, type is saving, some additional information, slightly part of that pertaining to that block, and some norms which are required to be used in order to extract and validate this information. And the next block value that is to be in the blockchain. So this is what that block information is. Now here in this we do require to know that how does this block works or blockchain works. So important thing is that when the multiple users, so slightly part of that panel have been covered by the Jitendra. Jitendra, please tell if that is already been covered or not. So multiple users who are required to put their information. In that case, the miners extract those information and validate them, and that takes time. So depending on that, how fast and efficient that can be done, the challenges are there that need to be met out. So we are working also in this part. Now coming to this part of this healthcare system, that in total. Is it visible, the text information? Now it is visible. So public segment, more emphasis in this liability issues that need to be handled. In that case, the current scenario, the latest update which we are having was that the 50% of that revenue that is being generated and using this supply chain management, it requires to have 46% of the revenue, and medical devices, robotics, which the Dr. Aditi Sharma has mentioned, that it covers that 41% of the revenue, and that depends on that the area or the region wise. The total market of this healthcare is 36% in the European regions. So a area is there where the healthcare issues are there, and people are issues of some healthcare services that need to be provided. In that case, if the quality outcome with that privacy, security, and accuracy, if that meets, in that case, the priority would be given. So likewise, in India, as per the statistics available, the foreign peoples where that cost of the medical treatment is too high to be borne by them, so they are relying on the services of the Indian institutes where such type of the healthcare services can be provided at the very ease of the cost. So in that case, more reliability and acceptability issues, if that would be there, more such type of that health travel type of that pattern that would increase. So issues pertaining to the blockchain is that we do require to know that how much that whether those information pertaining to that medicine which is being provided, how authentic is it. So in that case, each and every medical medicine, whether that may be injection or saline or any other equipment or tablet, they have their information or pertaining to date of manufacture and the expected time of their expiry, and at what and there's some signature values and the authenticity mark and some who has generated that, all those type of authentications that are mentioned, but that need to be recorded and that need to be marked. So pertaining to that, each and every medical prescription that goes through the person goes to a shop, medical shop, and procure those items. So it mentions that what is the expiry date of that particular item, of which category or which company that it belongs. And in that regulations pertaining to that, if the fraudulence or that fake medicine, if that has been generated, so in that case, it's a sort of that stamping or fake stamping that can be done. But if that information is stored in the blockchain and that has to be compared, in that case, we can easily identify that this particular match is already been there and it is the fake, or has already been consumed and this is the fake one, and that has to be discarded. So something like that is very much important to deal with, and a lot of exercise and the research and the resource requirement pertaining to that is there, and it should be mandatory for each and every medical institute or the hospital or healthcare system who are providing such type of the services should have such type of that validation technique. So in that case, a lot of issues pertaining to this real-time information exchange and use of the IoT for the remote medical healthcare services, it requires to have the proper validations and authentications. The security breach of the security would be a big concern. So to handle that, a lot of care that need to be made, and critically such type of the systems that are available over here in some other medical institute, which I have gone through in Jaipur, where the key company who has provided those platform or the machine, any patient who has to undergo the treatment using that machine, pertaining to that, the information has to be securely transmitted over there, and they will initiate the type of that treatment and how much that is to be provided, like the linear accelerators or the tummy tucking type of that cold treatment. Pertaining to that has to be remotely controlled, and secure information related to that person that need to be kept so that no other person can see that whether that person has taken such type of the treatment. So challenges are there. So in that, the blockchain is playing a very much key role in order to provide this authenticity of those medical healthcare issues, and that is a part of this talk that I am trying to cover. So as I said that all those medical healthcare information of the patient that has to be stored using this market tree, using the multiple number of the hash. So to minimize the size and provide the entire authentications of the multiple information pertaining to the patient that has to be put together and put in the block. Emphasis on this is because that the cost of the block in the blockchain is high, and keeping that record without a secure and the authenticity and pertaining to that using the miners, which gives that 50%, 51% of the agreement would ensure that this is a genuine one and that has to be validated. And pertaining to that, the cost need to be borne by the person who is availing this blockchain facility for their healthcare system. So either the medical institute or the organization or the hospital who are keeping the record in the blockchain, they would have to charge related to this information. So the cost of that treatment or the information that should not be imparted or shared with any other one, so that has to be managed by the hospital. So as we know that in the blockchain, there are the hierarchy and is a distributed architecture, variations of that is there, likewise, which has been mentioned over here. So in the case, a slightly organization wants to keep their own information, like in our institute, if I request to keep the information of the student or their record, either on the ERP or that has to be stored in the some other account or there's an account where that information has to be kept, and the database, all those information that has to be accepted. So three hierarchy of that multiple that can be centralized controlled, but in the entire world or in a big organizations where has the multiple centers in the global they have to use their services connected together, and they have to keep their records. So in that case, they cannot put everything in a centralized environment, but they have to rely on the distributed, but they will share that information. So the localized server will share their information with each other so to get update. And that is what has been mentioned over here. So the layer, as you know, that the account information, likewise, which has been used in the banking system pertaining to that the authenticity of the person who has created the account, and how much amount of the money is there, likewise, that what type of treatment the patient is going on, and which doctor that he has preferred, and what type of that uh, disease or that has been diagnosed, that has to be put in the record, and pertaining to that information has to be kept secret, uh, and that information need to be updated. If that has to be updated, in that case, it requires to create another block. And the previous information will be added, the new updated information has to be kept in the new record. So likewise, the same thing that new record of the any updations in that of that person every time, so that goes in that case. If that information is treatment that need to be given pertaining to be reported on the blockchain. So likewise, those information has to be environment that or that ransomware. You may be aware about that. Server system, the two were compromised. One which was compromised, the replica of that was immediately get extracted from that centralized or that distributed network to protect those informations, and those compromised systems were detached, and the new one attached with that security, and this the third one, the replica of that was updated. So is slightly part of that information, the latest updated information that was missed, but that system was secure. So the challenges are there pertaining to this, that the information that should not be compromised, and the security is must pertaining to that. Instead of decentralized laser, it is recommended that we should be having the distributed or the decentralized type of the laser environment. If someone has any question, please ask. So normally these 6 steps are there where that information is being exchanged on the record in the blockchain, and various type of the companies like which are mentioned over here, they are providing the blockchain services. So it is not pertaining to that only that the Bitcoin type of or the Ethereum type of data services. So Bitcoin using the blockchain is having the limitation that it requires to mine with a longer time. It takes around 12.5 12.5 minutes, and 2.5 minutes in the Ethereum. So the difference of this time interval is a big issue. So we need to have the better solution. So in that case, some such type of the companies like mentioned over here, along with this Quorum, Stellar, Ethereum, and Neo, they are the good one which are currently being used. So industry are taking the services of this company who are providing the blockchain services. Now, pertaining to this cryptographical services, the challenges are there. So, in a normal scenario, what happens is that in a blockchain, any information which has to be transmitted from the one person to the another person, that information should be reliable, that should be encrypted, and this should not be, if any other man in middle who wants to attack and accept that information should not be visible to him. So in that case, the best way is that we should be having a asymmetric type of the cryptography. So pertaining to that, only 4 type of that cryptographic algorithm existing. In that, the electrical cryptography, which the Dr. Jitendra has explored in the blockchain in his research part. Second is that RSA algorithm, which is a well-known algorithm, and the third is the algorithm, which is a very well-known key exchange algorithm, which are used in many services. And the latest one, with the Altamar algorithm, which is having its own encryption, and the security exchange key exchange methodology. So pertaining to that, all these 4 algorithms, which are claimed to be a robust one for a secure transmission, they are vulnerable and having a possibility of the man in middle attack. So we have a chart. I shall share that in the next part, which I shall cover. And in that case, the public and private key exchange methodology, which is well known. So symmetric cryptography is a simplified one, which is being used as a part of the two-key handshaking mechanism in asymmetric cryptography. In that case, the part of that is used as a common key sharing, which uses the AES-DES, which is having the same key. Likewise, unlike that, in the asymmetric cryptography, we also have the 2 keys, and that has to be encrypted and decrypted. So if that is there, in that case, the reliability of that becomes more, and authenticity of that is an important one. So the hashing is a very important part pertaining to this. So I will extend my talk pertaining to this because I'll have to cover the 2 parts pertaining to this blockchain and another part of this healthcare issues, which we have gone through for the vaccine distribution using the fuzzy inferences. So in this hashing, the information which is to be transmitted, that has to be transmitted along with that hash values. So either this text value or information or any other type of that information that has to be encrypted and that may be transmitted over the channel. So the challenges are there that how that can be done in a efficient way and more robust way without any compromise. So in that case, we have the multiple type of the hash functions that can be used. Pertaining to that, we will have to focus only this encrypted hash with the private signature values. So all those data, medical data or the healthcare data or the research or diagnosed values or whose value or hash function has to be generated and that has to be stored in the block. And this is a simplified version of depicting that how this block information is being stored in the blockchain. And this is what has been there, that all sorts type of that hash information is being stored in the blockchain. So pertaining to this, my specific part of that is that key, how can we use this blockchain for transmitting a secure transmission of the medicine to the multiple centers. So we may be having that center in the localized area, we may be having in the medium distance, large distance, or the very large distance. So the distance of this is there, and there are the constraints pertaining to that medicine or the vaccine or any other injections that need to be kept secure, that need to be marked, that need to be temperature controlled, that has to be transmitted using the transmission ways or their vehicle or dedicated vehicle, which are being created for such type of that supply chain. So in that case, we have explored the fuzzy inferences or the fuzzy logic base and combined that together with the blockchains for the smooth delivery of COVID vaccine. So this work was done after seeing that vulnerability and the fake vaccine distribution that was made during the vaccine distribution and their vaccination to the Indian people at large. So the concerning of this is that I will have to state that I may have to learn the systems to recognize and understand and recommend that what type of the decision that has to be taken. So pertaining to that, I may use the AI technique or that deep neural network techniques. So RNN, CNN, DNN, SNN are there. है ना? जो है in that the new one is that spiking neural network where that spikes are to be recognized in order to see that if the variation is there, otherwise the normal scenario that can be chosen. So pertaining to this, if any part of that which is more or that is a triggering only that need to be accounted and pertaining to that the solutions should be taken. So in that case, this SNN is a new part which has to be used in order to explore in a fast and efficient way compared to that the generalized way of the machine learning technique which has been used. So in that case, the time span of making the decision using this SNN is quite less, almost 80% less compared to that conventional method which is being used. Now, unlike that, where that the system required to be trained, another way is that the fuzzy inferences technique, where the rule-based techniques is required to be applied and that need to be not in the binary way. Unlike that, we have that variations and the flexibility that has to be available that we shall go through while discussing about this fuzzy inferences used on the fuzzy based vaccine distribution. So in this, what happens, let us look into a generalized scenario where the vaccine is to be distributed to the multiple healthcare systems who will provide those medicine or the healthcare services to the end user. So first that has to be generated and transmitted. So generation at the time, so the dispatching of that medicines at the time setting of that manufacturing date, expiry date, validations, marking the price, and some guidelines pertaining to that that need to be there, and it's trademarking or some marking on that stamping on each and every medicine which has been dispatched that is there. So the guidelines of that is followed by each and every manufacturing company who makes those type of the medicine. And now the second stage is that the transmission of that medicine to the cold storage or the warehouses. Now here that the transmission is having the challenges. that what type of that mode of the transmission we are using. Pertaining to that, the environment, location, and the distance that need to be covered. These are the challenges that has to be taken into the account. So in that case, the constraint pertaining to that has to be put that how much times that will take, how much the variations that can be there, whether that need to be compromised. If that variation is large, in that case, or the deviation is large, in that case, how to mitigate that. So alternate way of that need to be taken into the account so that the proper in-time delivery should be made. So constraint pertaining to that is at this very stage of this transit facility. Now, once that has been reached to the cold storage, and in that constraint will be carried forwarded with that expiry information. Only that how much time so that has to be kept over there, and in what way that has to be delivered to the next stage. So the mode of the transmission at each and every station that will be there. So from one station to the another station, or the one warehouse to the another warehouse, that has to be transmitted. So the multiple warehouse that should be there. So each and every the time is stamping of their receiving and the next delivery or dispatching that has to be marked. So pertaining to this information that has to be kept, and in that in the last that information or that medicine has to reach to the healthcare system, and either that healthcare services in house that need to be provided, or that has to be taken care at the medical health care center itself. So this is not that the flow of that medicine is in the healthcare system. So taking into the account this COVID vaccine distribution, you can see that some of this COVID vaccine requires minus 75 degree of the temperature. So the precise and in a fast and efficient way that the medicine has to be dispatched and consumed, that was a challenging one. And some of the country they have done very well without any compromise in the quality of the medicine or that vaccine. So fuzzy logic or the fuzzy inferences require the fuzzy logic which has the some fuzzy sets like the constraint based fuzzy sets and some linguistic variables. So as you can see that in the Boolean logic either true or false is there. But if I do require to have that variations, we can see that the cold, warm, hot, or variation of that intermediate, some very cold or that freezing, or the slightly warm, or the warm which is acceptable, or warm which is not acceptable, and hot or very hot. The variations of that is there. So in that case, the logic based constraint if that is required. So how much of this variations that you require to be to do, and in that case, the amount of that the rule pertaining to that would increase. So as you increase the number of the rules, in that case, more number or the more flexibility of acceptability pertaining to that would be there. That how much efficient and efficient way and the decision pertaining to that can be taken. So in that case, we can apply the AI techniques further in order to determine among them which would be the best one, and that can be incorporated. So in that case, the decision tree type of the base can also be incorporated in along with this fuzzy influence as well. So the concern is that if I'm having some medicine that is having a constraint pertaining to its temperature based on that whether that has to be accepted or not. So we require to put some membership functions, and based on that the output function would determine that whether that is a medicine should be considered for the distribution or not. So in that case, likewise, that the input membership functions are cold, warm, and hot. The membership function for the output is that measuration is kept in the cool constantly. Its temperature is not changed, and it is not heated up, or it has not been explored in the heated environment. So if like tetracyclic injection, if you keep outside, that will get damaged. So it has to be kept in the less than 16 degree or less than 4 degree temperature, likewise in the fridge. We usually kept that in a 15 to 16 degree temperature environment, minimum, maximum, and that should be less than the around 4 or 5 degree temperature. So various type of those type of that medicine, mostly medicines that are required or that are temperature sensitive. So how does the fuzzy inferences techniques implies to use the membership functions, like this cool function where we have to determine that if this input variable is less than 20 or minus 22, variation of that can be there, that if that variations from minus 20 to 20 is there, 24 is there, so in that case we can consider, or otherwise if the probability of consideration of that would be based on this rule. So in this case you can see that the 24 minus x divided by 24 minus 20, this is that membership functions. Based on that the decision has to be taken, that this is in the comfort zone, but this may likely to go in the warm zone because of this expiry, or the temperature is constantly increasing. So in that case, if that get increased, in that case that event that has to be discarded. So the precise and effective way of consuming that medicine in a most effective way to the patient requires that all these membership functions considered should be met, so that the efficiency of that medicine can be kept. So likewise for a, because we considering the three different criteria for sharing those medicine in a some catastrophic type of that environment, which we have seen in the COVID era. So likewise this membership function, we have the three different variations: freeze, cold, and warm. So as it depicted as a F, C, and W, and the range of that function is been mentioned like minus 25 to 0, minus 25 to 25, the entire cold part of that, and the warm from the 0 to 25. So in that case, the membership function diagram, so that gives this indication that this is the function depiction, clearly indicating that which region is a cold, which region is warm, which region is a freeze. And to that, the membership functions values and how to determine the function are mentioned over here with those type of that values. So either I may change this range pertaining to that type of the medicine that is used, and the environment where we are living, or whether that medicine has to be distributed in the June, July, or in the December. In that case, this the temperature variations can be there. So in that case, the flexibility is there to the healthcare system or that distribution system to moderate these values or the range, so that the acceptability of that can be increased. Now here this validity of this input variable is that pertaining to those type of that distance that need to be covered, the temperature that is counted for to accept that medicine. So if the medicine which is going to get expired because of kept that in more in the warm region, in that case that may get expired, or that may get ineffective unless that is in the healthcare or to the end user. So in that case, all those information of the medicine who's supposed to expire, that information need to be exchanged, and the degree of acceptance of that or distribution should be high, or dispatching of that medication should be more, so that that should be consumed. So wastage of the such type of the medicine is a very big concern, and that plays a very big loss, or the cost of that is very high. So in that case, the challenges are there that having those medicine which are close to expired, that has to be delivered immediately, or the period of that should be specified, and the priority of that should be given. So the priority of assigning and the changing of that should be more. So in that case, around to expire, that means that we have this 3 month time, like which is mentioned over here, or for long period of the time, so the 5 years, 4 years, if that is there. In that case, you can keep that longer period of the time in the warehouse, and regularly you can display that. So the priority can be varying based on that degree of the degree of that membership functions, and expiry of that medicine. The other part, because we have considering 3 parts in this, and that can also increase based on that constraint we can apply. So the 3 things are there. That one is that the the temperature. Second is that which I have mentioned, that the period of time in which that medicine need to be kept, and the distance that need to be covered in order to deliver that medicine to the end user. So in that case, the multiple hopes may be there, or dispatching centers, the carrier forwarder that would be there, so that that medicine has to be delivered to the destination. So एक है नजदीक, थोड़ा और जो है उससे दूर हो गया, कुछ ज्यादा दूर हो गया, बहुत ज्यादा दूर है. So in that case, beginning from that the foundry, or that factory, and that has to be dispatched to the end user, all this time stamping and the distance that need to be covered, that plays a very important role. So pertaining to this dispatching and delivery of the product, we have the inferences membership function, like very short distance, medium distance, large distance, and the very large distance. So 5 different type of that variations is there. So 5 into 5, that means it will be having the 5 raised to the by 5 multiple such type of that constraints that can be there, and that can be put together. So in that case, how much you are considering as a part of that fuzzy rules, you can explore them more and make that system more efficient and reliable to deliver or dispatch that medicine. So here we have considered this 5 number of that description, or the membership functions. So as I said, that these fuzzy rules are required to be made, and in that case, the based on that, the matrix is required to be created based on those, whether that is allowable, and that has to be displayed. So we have this 3 different type of that functions, one for the validity, one for the temperature, and one for the distance that need to be covered. So with this, as you can see here, that the rules which are to be created, based on that the decision has to be taken. So if the temperature is freeze and validity is there for as an FE, which is as efficient than the freeze and acceptable, and the distance is a very large distance. So in that case, we may keep that longer periods of time in the warehouse. But if the medicine is become warm, and it is has to be covered, okay, and in that case, the very short distance has to be used in order to deliver that medicine. And in this case, if that has not been delivered, in that case, that will be the expiry state, and that may never be consumed because ये आपकी और हमारी हेल्थ केयर से रिलेटेड है. तो इस केस में if suppose the membership functions values are which we have gone through, like the temperature is varied of cool and warm, the validity of that is let us say the 20 days, so that will be in the close to expiry, and so in that case this close to expiry part CE and the around to expiry, this will be in between of these two. So as you can see over here that the close to expiry, okay, so the close to expiry and around to expiry, so this will be in this very range, okay. So in this very range implies that the medicine has to be delivered in the fast and efficient way, and if that would be possible, deliver that to the nearest healthcare center. And pertaining to that, this is the metrics that has to be used in order to determine whether that constraints are met and the type of the decision that has to be taken into the account. So here you can see that according to this rule base, the constraint base, we have the 4 different type of the rules which are to be counted in this, that the temperature is cold and valid, which is close to expiry, and another is that around to get expired, and its temperature is warm and the validity is close to expiry, and the temperature is warm and the validity is around to expiry. So the 4 part of that cold and warm and around to expire or the close to expire. So close to expire is a big concern, and if it has been warm, in that case, deliver that as fast as possible. And if it is the cold but close to expire, in that case, it can be possibly distributed to the close center. So constraint pertaining to that deliver can be managed using this rule-based evaluation and distribution. Pertaining to this, the values if just based on those which are mentioned over here in the left-hand side. So if these values are considered and if that are provided like mentioned over here, and based on that formula, the values of those is determined, so that will fit over here in this rule matrix. And as you can see over here that which one is that minimal one, in that case that mean to the max values of this is that the medium distance can be covered easily for this the medicine distribution. So because this determines that what is the maximum strength on that, and in this the S2 is giving that maximum distance. Is it clear? So S2 implies that it is around to expire and currently in the cold storage, and that is having this 60% chances of getting validated again there, and it will not get expired. Whereas the medicine which is warm and close to expire, the probability of using this will be very less, means around 92% that if it is not been distributed, it will get expired. So in that case, the priority of that should be there, and that has to be taken into the account. And the another one is that which one would be the best one, or that flexibility is there where I can distribute that to the longer distance, and with that maximum period of the time, validity time. In that case, I would have to prefer this medicine which is having the constraint which are mentioned over here, that this value, this medicine which is having those strength S1, S2, S3, S4, and that meets this values, So in that case, it is having a larger period of the time of unlike the other one, and very less amount of that is there, that would be consumed, but the maximum amount of that medicine that can be transmitted in the medium distance centers. Okay, so in this likewise we have this another membership function, rule-based membership functions, with for the different variations of the distance. So if the distance of that is been considered, in that case we can have those type of the scenario where we can assume that the medicine which has been a temperature controlled or and they have one that and the expiry constraints are there. So in that how far and how much time that need to be there under which that medicine can be distributed. So here is an example that the temperature is a 2 degree and the 20 days time, which we have mentioned. So in that case, the distance that can be covered is approximately 400 kilometer that can be there. So in that case, this is what we expect and that has been there. Now I will cover another important part, that all these type of that medicine who has to be transmitted using these fuzzy inferences, where we need not require to go for the deep learning technique where that system required to be trained. Only rule-based services that will be an efficient way in order to deliver those medicine efficiently in a catastrophic environment. So, but like wise I stated that stamping of that on the blockchain is a good criteria. So in that case, the hashing has to be used. So what is this hashing? How this hashing is generated, or the hash function is being generated? That part will now I shall try to cover within the next 15 minutes. So Agam, Mr. Agam.
Yes, sir. I'm here. Yes, sir.
So I will extend my part to this 15 minutes more, so that you may ask the next person, because the next session would start after lunch, I think.
Yes, sir. Next session will start at after lunch, sir.
I will cover that. So 15 minutes, not more than 15 minutes I will take. So variations of this Shaw algorithms are there, and in this the most common is the 256 Shaw algorithm. Okay, so in that Shaw is like for the secure hash algorithm, and the variations of this type of the algorithms are there, and mostly this is a common big use. So those people who are aware about the networking, we use this the last every packet which has been transmitted the frame check sequence or the CRC is been used. So likewise the CRC, which is of the 32-bit, which indicates that message which is being transmitted, that is valid or not. Or the checks that RCC with that same polynomial generator polynomial that has to be tested at the receiving end, and if the variation is there, in that case, and the packet either if no variation is there, in that case it is considered, otherwise that will be discarded. The same thing would apply here in this case, that every information which is pertaining to that the Shaw value of the 256 byte value, that has to be put in the blockchain. So anywhere in the round world that can be taken into the for the consideration of the testing, that whether that information which we are using that is correct or not. So in that, like आपकी टिकट मार्कशीट है, आपने कुछ नहीं करा किसी ने उसके अंदर, तो वो अगर एक रजिस्टर सिग्नेचर वैल्यू है उसमें ब्लॉकचेन पे है, तो अगर उसने चेंज करा है वो कहीं दिखा रहा है, और वो उसको टेस्ट करके उसको चेक कर सकते हैं ये जो इन्फॉर्मेशन इन्होंने दी है और वो ब्लॉकचेन पे उसकी इन्फॉर्मेशन स्टोर्ड है वो दोनों सेम है या नहीं, अगर नहीं है तो उसको रिजेक्ट कर सकते हैं. सो यहाँ पर that part which I will discuss is that only this SHA-256 algorithm which is commonly being used, and till this date, there is no as such that breach of this. Somebody claims that that has been breached, and the new variations of this factor has been there, but the complexity of such type of that becomes more. And the SHA existing 256 is nowadays is commonly being used. So as you can see that this variations of this algorithms in the message digest algorithms, the block size of that is varying, and the amount of the steps which are required. So as this SHA is 256 having the less number of the steps and uses the 32-bit count, and the block size of that would be used for the message is 512 byte, and we can go to the 2 raised to the power 64 size of the message. So nowadays, what we have done in our institute that we have synthesized this SHA-256 algorithms on the chip so that any message which is being generated and transmitted over that chip pertaining to that the signature value is being generated. So no external program pertaining to that is required. So only that the actual programmable gate would compute that 256 hash values and embed that with the information which has been transmitted, and that is a signature value assigned with that. So like that has been used in the camera, like that has been used by the forensic department to take the snap of the incidents that they want to consider. Likewise, I have gone through such type of that equipment and validated them, and in a National Forensic Science University, I awarded 5 lakh rupees awarded to that organization who has made that practical implementation of that digital forensics device for taking the record or keep taking the record of the incidents. So things are improving in India also, that we are having such type of that facility available which can be used. So now coming to this short algorithm, I will just go through that how this is being used. So likewise, any type of the data, text, image, or audio, video that can be generated, a slightly variation of that would give that this cannot be considered, and variation would give that entire change of this hash value. So in that case, that will be simply discarded. So a lot of issues pertaining to this is there, that either we do require to use that information in a encrypted way and then use the hash value, or a simple register information and that will be directly transmitted without any changes. Only because that depends in that case whether at the intermediate level we do require to make a encryption of that information which is to be shared, or the simple information along with that hash value that will start with जो हम नेटवर्किंग के अंदर यूज करते हैं. So इसमें like that variations is there, we cannot change anything, and it allows any data, any size of the data. So how much amount of that data is 2 raised to the power 64? That is a large data set that can be messages that can be taken and whose hash values can be computed, but that computation time will be more. So it is preferable to use the 256 SHA-256 algorithms, which is fast, and use the 512 byte at a time and repeat that continuously until all those messages be computed. So in that case, the every variations of the data that can be there, it can be easily identified, and no other person can, if they try to align that information and transmit that, in that case, the end user can validate that to the blockchain. So here, the secrecy of this 256 value that is to be there. So any message with that hash value. So we have this message with that secret or without secret. दोनों चीजें उसमें possible है. So the secret key is preferable to transmit that message. So what it implies is that any size of the maximum up to that 264-bit values that can be used, and the blocks are to be created in the blockchain. So every 512-bit block that has to be given. So in that case, the SHA-256 values that generates the hash values of the 256. That means the total number of this 8-byte values that is to be created, 8-word hash values. Okay, and that pass to the next, and each and every time so that is to be created. So all those blocks that are to be taken, whose values of that using this SHA initial values with that initial hash functions that is to be taken, and that is will be passed forwarded to the next one, and it goes on. So take an example of this SHA-256 algorithm that we have an input message of any size. Okay, so in that case, if suppose some message which is not in that accurate bunch or the fraction of 512, so remaining part has to be added with the zero, added with that from the total 512-bit. So if that part is missing, in that case, it has to be padded with that. So this is very important, and I have taken because the size of that packet should be or that message block which are being created, that should be fixed in the size. So the last part of that message of the block that may not be of 512 bit. So in that case, it has to be padded with the remaining part. So now here you can see that once we have taken this 512 bit as a part of the message that has to be given for the compression, and initial hash values that has to be created. So what is this initial hash value is that I shall depict in the next slide. And some key, you have 64-bit key values that is to be taken into the account. So two part, this key values and the hash values along with this block that has to be taken into the account, and give this for this compression, which generates a another and it operates computes in the 64 round of the compression, likewise mentioned over here. That this logic of this is mentioned over here, that it has this two different stages that are been created, and based on that the final weight of that has been created, and using which the values of new values of this 64 0 to 64 byte and 64 bit that has been created. So now this new value of this, so you can see over here that we are having three part key values, which is here, hash value here, and the message here. Churning is there, which is being done at the compression. The compression logic is mentioned over here, and this compression it carries on by taking this new values and adding the hash value with that new value of this first stage value which is been generated. So you can see over here that this hash value which is also been used over here as and the new value of the churning of this with that compression is been generated and added with this hash value. So it is an XOR adding which has been done over here, and then pass that with the new message and the key value. So key remains same, hash values remain same, initial values, but the churning of this with that compression which gives this new values of the hash at the first stage, that has to be embedded with this hash value, and added with the another next 512-bit information and pass to the next compression. So up to the 8 number of the times or n number of the times up to which that size of that message is, it has to continue, and in the last we get this final hash value. So in this, the simplified logic pertaining to this creation of this in a synthesized model that becomes an easy one, because of the initial part of this key values and the hash values which are already been provided. Only that exchange of this information in this compression formula along with this message, truncated message of the 512 bit, that has to be taken into this logic, which will generate the hash value and it will add that. So it comprises this entire hash function in a smaller way, and it enhances the output in the quick and the fast way if it has been compressed and synthesized in a field programmable gate array. So as you can see over here that the padding is been done for the message in the last, if the message is not E1 or that last of 512-bit message is not completed. So in that case, let 512-bit is having a m number of the bit, and it requires to embed the last bit. So this the padding bit, the very first padding bit that indicates that this one indicate at this that this is a padded one, and how much this padding of this 0 has been done, and that would be taken or added with that message, and this would complete this entire last message bits and complete that block which would be given to the blockchain. So making this become a simpler one, and we would be able to compute this entire message of any size, likewise which is mentioned 640 bit which is mentioned over here, and in the last bit we are making this padding using this indicator as 1 and the number of zeros which are being added to complete this 512 bits. So as I said that this is 0 to 7 hash values over here. Yeah, the initial hash value है this is what looks like this. Okay, I'm sorry, this is what this hash values. So this is fixed. It has been decided, this has been generated, and this is fixed, and this would remain same. There no change in this, and the key values which has been used, this is the 64-bit key values which has been used. So these are the predetermined fixed values which are being provided to the compressor, which will compress this information using this logic. So all these values which are being provided, it along with that data input, it compress that and generate the new values. And there are the many rotations and XOR operations, and using this the final value of this ABCD is there. So it is not necessary that the ABCD which has been generated here that would be in that same order. You can see over here that the value of this ABCD is changing. A is here, but it is B over here. The last one is added as A here. So this is a compression logic which is not a reversible. So something which is already been done, so that will remain same and that cannot be altered. So the key values are there, and this description which I already stated about this generation of this S0, S1 and S2 logic, S0 and S1, and this CH and MA for exchanging this, combining them together, and the final value of that is generated by shifting and adding together in this way. So the logic is a critical one and a specific one, which has its own values, and that is why the advantage of Beauty is there that this algorithm is non-reversible. Once that hash value is generated, that will remain same, and no one can change that. Any variations in the input that will not be acceptable, and that will not be acceptable. So thank you very much for bearing with me. I discussed that fuzzy inferences values and the SHA algorithm, which has been used in the blockchain for putting this hash values or the signature values in the block. And the next part of that I shall cover using this Chinese reminder theorem for the medical healthcare system in the next talk as per my assigned schedule. Thank you very much.
So thank you, sir. Thank you so much, sir, for giving such a nice talk on SHA and how this SHA works, how the blockchain mining works, how the rotation, the message is divided into blocks, and so on. So I request the participants, if there is any query regarding the talk, then you may ask in the chat box or like.
So I think the chat box is enabled. Any query pertaining to that, if it has been there, kindly put that on the chat box. So Agam or Dr. Jitendra, they will dictate that, and I will try my level best to give the answer.
Yes, sir. Yes, sir. Yes, participants, is there any questions from your side or any query regarding the same? You may write in the chat box if you have any doubt, or
I
you
suggest that, Dr. Jitendra, what I would suggest that you take those questions in the chat box, and we will make the answer and share them.
yeah. So that will be good for all the participants and for us
I'm
also.
already over with this time. Okay.
We can understand your busy schedules actually. So we appreciate your time. We give you lots of thanks for giving such a wonderful talk on the working of the SHA and the rotation of the SHA, how the message is divided, and the churning in SHA also was the very useful concept in the blockchain technology. So thank you so much for giving such a nice talk. And so to all the participants, the next session will start at 1:50 after the lunch. Okay, so I request all of you to be there at 1:50.
Thank you.